Okay, this lesson is about the dreaded motion problems. People have a hard time with this. If you ask any adult, they'll tell you nightmares about these, but we're going to work through it in a way that I think you guys can handle it, and I don't want you to be intimidated by it. I think this is going to be manageable, so hang in there with me, okay? So, here we go. A train leaves the station at 1 p.m. It travels at an average rate is another word for speed, of 60 miles per hour. A high-speed train leaves the same station an hour later, but it travels at an average rate of 96 miles per hour, so it's going faster. The second train follows the same route as the first train on a track parallel to the first. In how many hours will the second train catch up with the first? Oh my goodness. Okay, so I am going to always give you a table for these in Algebra 1. When we get to Algebra 2, you won't always have a table, but in Algebra 1 you will. And the table is really, really helpful. Okay, so if we sort of fill this in, this is what we want to think about. We have two trains. Let's call this train Train A. Maybe. We have Train A. And let's call the second train Train B, just for lack of a better word. Okay, rate is their speed. So the first train, the one we called Train A, it says it travels at a rate of 60 miles per hour. So I'm going to put 60 miles per hour right here. And the second train, the one that's traveling faster, travels at a rate of 96 miles per hour. Okay. Time is how long they've traveled for. So if you look through this, does it say that train A traveled for 4 hours or 1 hour or 12 hours? It does not give you how long train A traveled for. So I am going to put a T in there because I don't know how much time it traveled for. Also, if you read the question, in how many hours will the second train catch up with the first? That's a hint that you don't know the time, and you're going to have to figure that out because you're looking for something in hours. Okay? Now, train B, a lot of people think, well, you don't know how long that train traveled either, so let's call it T. The problem is A and B did not travel for the same amount of time. Okay, I'll say that again. A and B did not travel for the same amount of time, so you can't just put in B or T for train B's time. Okay, but here's what you know. This is key. The second train follows the same route, okay, but it left an hour later, okay? It left an hour later. So what a lot of people want to do right here is take T and add 1 to it. But here's what I want you to think about. Let's say it took train A 6 hours, okay, to get to one spot. If train B was following on the same track, but it left an hour later, train B, it would take 5 hours only. It's going to take less time, okay? If it leaves an hour later, that means it's spending an hour less on the track than train A did, okay? So I don't know how far train B traveled either, but I know it traveled however far train A traveled minus 1 hour because it got to wait an hour. So it will spend an hour less on the track, okay? Now, you need to be familiar with this equation if you're not, and that is distance equals rate times time. Okay? So train A's distance, basically I'm going to multiply these two things together. So the distance for train A, rate times time, 60 miles per hour times t would be 60t. Okay? Then here I will have 96 times the quantity t minus 1. I'm going to multiply those in there. Okay, so now I've got my table filled out, and it says in how many hours will the second train catch up with the first? So basically, if it catches up, so basically this train leaves and it heads and heads. This train doesn't leave till a little bit later, but it waits and it leaves. And in order for them to catch up, basically if they are caught up to each other, this is the same. And this is the distance that they've traveled. So we are looking for where their distance is, where train A's distance will be the same as train B's. So now I can make an equation where train A's distance is the same as or equals train B's distance. Okay? And now I'm just going to solve for t. So 60t equals, and I distribute the right side, 96t. 96 times negative 1 is negative 96. I will subtract 96t, and I'll have negative 36t equals negative 96. Divide by negative 36. And t equals 2.66666 repeating if you do this on your calculator, or 2 2/3 hours. Okay? Now, that's what t is. However, we solve for t, but that's not necessarily the answer. I want you always to go back up and read the question again. The question is, in how many hours will the second train catch up with the first? Okay? In how many hours will the second train catch up with the first? And basically that's asking you is, in how many hours is the second train on the track? Okay? So notice when I solve for t, t in this case was the first train. But I'm asking you, in how many hours will the second train, or train B, catch up? Okay, so when I take that, basically to answer that question then, I need to subtract 1, and t will be 1 2/3 hours. Okay? All right, we'll do another one here. A moving van leaves a house traveling at an average speed of 35 miles per hour. The family leaves the house 3/4 of an hour later, following the same route in a car. Okay? So you've got a moving van and you've got a car. Okay? The moving van is a little bit slow, so they travel 35 miles per hour. The car travels, if you read, at 50 miles per hour. Okay, now I want to figure out time here. All right. So I don't know how long the moving van has to be on the road, but the question is, how long will it take the car to catch up to the van? So very similar to the last one. Okay, this time I'm going to do this a little differently. The question is, how long will it take the car to catch up to the van? So my question is, how long will this take right here? Okay, so the car traveled for t hours. Okay, because our time is in hours, because it's miles per hour. So our time is in hours here. Now, I'm doing this one backwards from the one I did before, and you can do it either way. So I want to show you it both ways so that you can choose which way works better for you. Okay? So I put the t this time with the car. I don't know how long the car was on the road, but I know that the van left before the car. Okay? The van left 3/4 of an hour before the car. So that means that the moving van was on the road longer than the car. Okay, so if I'm going to do it this way, then this needs to be t plus 3/4 of an hour. So it was however long the car traveled plus 3/4 of an hour. All right, again, we know that distance equals rate times time. So in order to find our distance, I will just simply multiply these two things together. So I will have 35 times t plus 3/4. And then I will have 50t. Okay, and here again, they're traveling along the same route, and you need them to catch up to each other. So I will have 35 times t minus 3/4 equals 50t. And I know that these are not necessarily super pretty numbers, but we can handle this. All right, so I'm going to take 35 times t, which is 35t, and then 35 times 3/4 would be 105/4. equals 50t. Okay, then I will subtract 35t. And I'll have negative 105 over 4. 50 minus 35 is 15t. Okay, now I know you've got fractions in here, so don't panic, okay? You can divide by 15. And by the way, dividing by 15 is the same as multiplying by 1 over 15. Okay? So don't panic there. So t would be negative 105 over 15 times 4, which is 60. And something is not right. Oops, that's because when I did this up here, guess what I did? This should be a plus right here. T plus 3/4. You guys probably caught that well before I did. Plus right there. And so then this is positive 105 divided by 60. Sorry about that. All right. And so then T, when you do that, becomes 1.75 hours. Our time is in hours here. But now, T might be the answer to the question, and it might not. You might have to do something else to it. So let's go back up and read the question. The question is, how long will it take the car to catch up to the van? So I'm asking you, how much time does the car have to be on the road? Notice T is the car's time because it's in the car's row. So I actually answered the question directly right here, and I don't need to do anything here. So 1.75 hours. All right, last one. Nora drives into the city to buy a software program at a computer store. Because of traffic conditions, she averages only 15 miles an hour on her way in. Okay? On her way home, the traffic must have cleared up because she was able to average 35 miles an hour. Notice she's going on the same route. Okay? So if she's going on the same route, her distance there has to be the same as her distance home. All right, her total travel time is 2 hours. How long does it take her to drive to the store? All right, so here we go. This will be to the store, and this will be back home. Okay, this is a little different here, but to the store, she travels 15 miles an hour, and back home, she travels 35 miles an hour. Now, I know that it took her 2 hours total to be on the road. However, let's say this is home and this is the store. If it took her 2 hours total, you got to remember that she is not traveling at the same speed. So it's not going to take her 1 hour to get there and 1 hour to get home. It might take her an hour and a half to get there and only a half an hour to get home, or some variation of that, okay? But it is not taking her the same distance to get there as it does to get home. But this is what I know. If I want to answer the question, how long does it take her to drive to the store, I am going to put the T right there so that it answers my question. How long does it take her to get to the store? Okay, now, to get back home, I don't know how long it takes her to get home, but I know that it has a 2-hour round trip distance. So if it was 2 hours, and let's say T was 20 minutes, then if it was a 2-hour round trip and T was 20 minutes, it would take me an hour and 40 minutes to get back home. Okay? Or let's say T was 50 minutes. If to get to the store, this T right here was 50 minutes. To get back home, I would take 2 hours minus 50 minutes, so that would mean it would take me an hour and 10 minutes to get back home. Okay, do you see what's happening here? So in order to get back home, basically I have to take that 2-hour round trip and subtract the part that I already used to get to the store. Okay, so that's what that should look like. Again, distance is still rate times time, so I will multiply those two. 15 times t is 15t, and 35 times 2 minus t. Again, since I'm traveling the same route, my distance will be the same, and I can just make an equation where I take the to the store's distance, which is 15t, and set it equal to the back home distance, which is 35 times 2 minus t. Since I'm traveling on the same route, their distances have to be the same. Okay, so I have 15t minus, I will distribute over here, 70 minus 35t, and then I will add 35t. And I will have 50t equals 70. Divide by 50. And t will be 1 2/5 hours, or 1.4 hours. Okay? So t is 1.4 hours. Again, I want you to read the question. And the question was, how long does it take her to drive to the computer store? So notice I have t on to the computer store. So I have answered the question when I solve for t. So that is what that should be.